Hi, everyone, and welcome to this talk about doing forensic analysis on real incidents inside Microsoft Remote Desktop Services, aka terminal services. The objective is to quickly introduce what an RDS environment looks like, then mention how to compromise and investigate such environments, talk about real-world attacks, and finally go through some recommendations and how companies can further protect themselves against in these kind of environments. So let's get started. I'm Catarina, an incident response consultant at ITsecurity, formerly known as F-Secure Business, based in Helsinki, Finland. I am a former security researcher and malware analyst, still at F-Secure ITsecurity. And for the past couple of years, I've had the opportunity to be a guest lecturer at the Finnish Aalto University, where I've given lectures about Windows forensics, as well as Android malware analysis. So regarding the premise of the talk, with the rise of remote work and cloud computing, companies have been forced to take a closer look at remote access solutions. There are many examples and use cases where remote access solutions can be deployed, for instance, to enable remote work, in a bring-your-own-device policy, if companies have it, because in that case, companies are encouraged to deploy a virtual desktop solution. For task or shift work, so employees can access a remote app, for graphic-intensive applications, and the list goes on. Among the most popular solutions, we have Citrix XenApp and XenDesktop, VMware Horizon, Microsoft Remote Desktop Services, and Azure Virtual Desktop, which is basically Microsoft's implementation of RDS, but in the cloud. So among the solutions, all these solutions here, I decided to focus on the Microsoft Remote Desktop Services. Because a couple months ago, I had an incident response case where I had to investigate such environment. And there was no resource, really, that gathered all the information that was relevant when conducting an investigation. Everything was a little bit scattered around. And so the objective is to mention the specificities when investigating such environments, and just what we need to keep in mind when investigating, and what we need to ask the client as well, like in terms of forensic acquisition. The second reason is that RDS is native to Windows Server. It's relatively easy to deploy. It relies on RDP. It is used in various corporate environments. And since it can be publicly exposed, threat actors and malware campaigns can target it. If we look at recent news articles about attacks and vulnerabilities affecting RDS, we can see that back in 2020, a proof of concept for a denial-of-service exploit was published that would target RD gateways, which are the entry point for RDS environments. A couple days later, that same exploit was improved and became a remote code execution exploit. And that really alarmed the cybersecurity at the time. And now, more recently, in October 2022, it was reported that the Venus ransomware threat actor was targeting those RDS infrastructures. If we have a quick look in Shodan to try and identify publicly exposed RDS environments, we can see that, so in this screenshot from May 2023, there were around 43,000 potential RDS environments. And the query that was made is that we tried to identify RD web access servers because they will usually run on an RD gateway, which is the entry point. And so, because of all these reasons, this talk will focus on RDS. So there are different components and roles that can make up an RDS environment, and we'll go through them in the next slides. The first one is the RD web access role, which basically allows access to remote desktops and/or remote apps via web page, or the RDP configuration file can be downloaded and then imported in an RDP client. Here's an example of what the RD web access login page looks like. Then we have the RD gateway role, which will receive the incoming RDP session requests, which will be encapsulated in TLS, and then forward them to the correct server. By doing that, it prevents some RDS components, and in particular the session hosts, from being publicly exposed. At the RD gateway level, we have the RD authorization policies are defined, and they can be either the connection authorization policies, so meaning which users are allowed to connect to the network, or the resource authorization policies, so which hosts do the users have access to. The next role is the RD connection broker, which is responsible for forwarding the RDP sessions to the RD session hosts. And the RD connection broker can also act as a load balancer. Next, we have the RD session host. So that's the role that, or in a deployment, we can either have then a session-based virtualization or a VDI deployment. And within those virtualization environments, the user, which will connect via RDP, will either have access to a remote desktop or a remote app. Then regarding the user-specific files, they can be stored in user profile disks, which are in the VHD format and are automatically mounted when the user logs on into an RD session host. Last, there's the RD license host, which is a dedicated server which has and hosts the RDS licenses that are needed. And so this is what a typical on-premises RDS deployment looks like, with all of the parts we just mentioned. And we have the public-facing roles, so the RD web access and the RD gateway here. They are in a DMZ, so because they are our public-facing roles. We can see that the external devices only communicate with those roles, those servers in this case. Then we have the RD gateway, which will either directly forward the connections to our session hosts or via the connection broker. And all of this environment needs to be in an Active Directory domain since Windows Server 2012. Now let's deep dive into how such infrastructures can be compromised and identify the evidence that is relevant during an incident response case. In a typical RDS environment, the public-facing roles, so the RD gateway and the RD web access, will be targeted first. The RD gateway will be the entry point, and the RD web access can be leveraged to identify valid domain user accounts without providing a password. So with an RD gateway, there's a false sense of security, because we assume that since the RDP servers are no longer exposed to the internet, that they are safe. And that is not entirely true. It's better than just having RDP alone, for sure. But the attacks that target RD gateways are similar to regular RDP compromises. So we'll have brute force or password spraying attacks. Valid domain credentials can be obtained by an attacker and then used to enter the network. Or vulnerabilities can be exploited to gain an initial foothold into the system. In order to demonstrate real-world attacks and highlight detection opportunities, a lab was created. So in this case, we can see our attacker here. We have its public IP, and the objective is to breach an RDS environment. To do that, the connections are forwarded through a router, and they can either end up on the RD gateway or the RD web access server, which are the public-facing ones. But in this case, the RD web access server is also the RD connection broker, as well as the server where we are going to store our user profile disks, so the user-specific files. And this is not the recommended deployment we saw early on. Next, we have one session host, which will have a remote desktop and will be hardened to limit the damage that a regular user can do. In this lab still, we will have another computer running Windows 11, which will be an RDP host. And last, we have our domain controller. So the first objective for a threat actor is to acquire domain credentials. And there are mainly three big steps that can be done here. The first one, the threat actor needs to determine the domain name and then the username pattern that is applied at the company level. So for the domain name, the threat actor can look at the workspace ID hidden input field in the RD web access login page, for instance. And for the username pattern, the threat actor can rely on OSINT and, for instance, find a work email on LinkedIn. Next, once we have the domain name, the threat actor can try to identify valid domain user accounts by doing an anonymous authentication timing attack on the RD web access server. The last step, once we know what accounts are valid, the objective is to obtain the account's password. So to do that, the attacker can, again, use brute force or password spraying attack, or it can target a specific victim by sending a phishing email. There are, of course, other ways to enumerate domain account credentials, but these were the ones that were simulated in this attack. And so throughout the demos, Chainsaw, an open source tool developed by WithSecure, will be used to parse lesser-known Windows event logs. And a new version of Chainsaw will be published right after this talk to take into account the detection opportunities that are illustrated in this presentation. And in the next slides, only the most relevant Chainsaw outputs will be included. And so now it's time for our first demo. Let's remove this. And so here the first step in the attack was to run an nmap on the RD web access server. And we can see, as expected, the ports 80 and 443 that were opened. So the threat actor could next go to the RD web access login page, inspect it, and find the workspace ID input field. And in there, its value will have the machine name as well as the domain name. The next step, once we have that information, is to start our anonymous authentication timing attack. And to do that, the threat actor can have a file containing usernames that is going to be used, and that's the case here. And for this attack, 3 different variants of usernames were used. The next step then is to start Metasploit, because Metasploit has a module that will allow us to perform that attack. And so here it's loading, and we choose the correct module, and printing the different options that it has, and we are now going to set them. And so the first one will be setting the IP address of the RD web access server, which is our target. Then we'll have the domain name. After that, the timeout. So after it's the response timeout, after which a domain name user account is no longer valid. Next, we have our list of usernames that we're going to try. And here, all the options have been set. And before running, on the right side, you have here the real-time events on the security event log, because this brute force attack or this authentication timing attack will be seen here with failed logon events. And so if we start to run it, we can see a lot of failed logon events on the right. And if we fast forward to the end, we can confirm in the event viewer that there were indeed those malicious, those failed logon events in there. And so clicking it, and here it is, so the same thing. And now if we go back to the Metasploit module and enumerate the credentials that were retrieved, according to this, we have identified a couple of valid domain user accounts. But all the requests always failed. So this is the first step. We have a list of valid domain user accounts. So we create a file containing that information to then brute force the password to it. So we, again, have another file containing common passwords that can be used. And we'll, again, use the same module, Metasploit module, but this time updating the username list and the password list that we're going to test. And if we rerun the attack, and again, the real-time events on the right, we have, in this case, failed logon events, because the first user was actually not a valid one. But in the end, if we fast forward, we can see that credentials, valid credentials, and accounts were identified. And so with those, we can now go to the RD web access login page and download the RDP configuration file that will allow us to log into the network. And so this is what it quickly looks like. And the target server, so we have information about the connection broker, the gateway, and so on. And in this demo, Remina was used to connect to the company's network. So specify a name, we get the username, password, and as mentioned here, the server is the connection broker, not the session host, which can be a little bit unexpected, but the connection broker will then forward the connection to the session host. So here we set the different parameters, the domain name. We're also setting up a shared folder, so the attacker has its tools when it connects to the environment. And then if we look at the advanced parameters, we have the RD gateway that is mentioned, as well as the load balance information, which is basically to which RDS collection the connection request will be forwarded to. And so now, once everything is set up, we can start and connect to the RD session host. And in this case, we have a successful connection. And we can confirm that we are indeed in the session host by looking at what computer we are. And this is the case. So we have the RDSH01 in here. The next step, we can confirm that we have our tools that were mounted, and that's the case. And here we can notice that on this server, the user specific files are in that user profile disk that is used. And to actually get the path, we can look at the registry. So here is just the threat actor cannot access any other of the folders. And in the registry, we can see exactly where the user profile disks will be. So in this case, it will be in the connection broker. And finally, with a little bit further reconnaissance, we can try to find out which Windows Defender version is running as well. So the brute force attack will be visible in the Windows event logs of the RD web access server, or on the RD gateway, depending on which server was targeted in the attack. In our case, it was the RD web access. And so we'll have in the security event log the failed logon events, as well as the successful logon events, in case there was any successful ones. And with Chainsaw, we can easily identify brute force attacks, as we can see on this image. So these were the different accounts and usernames that were tested. In case of a successful connection, we will see a 4624 event in the RD web access server. And if we take a closer look at one of the values, which is the subject username, as well as the subject domain name, this will indicate that the successful connection happened via the login page. On the RD gateway, the Windows event log named Microsoft Windows Terminal Services Gateway will contain events regarding the authorization policies, so these first two, as well as events regarding the connection and disconnection of a user from an RD session host. Regarding some key takeaways in terms of investigation and when you're analyzing these events, the attacker's public IP address won't be visible in the RD web access events. It will, however, be visible in the RD gateway events. And if we take a closer look at the last one, the event 303, it will have information about how many bytes were transferred, received, and the duration of the RDP session. And this is really interesting because it can give us an overview on how much time and how much information, what happened when a threat actor logged on into the RD session host. This is Chainsaw output for successful logon events on the RD web access server. And we can see that the IP address was stripped. Here we don't have the information. And this is the output for the RD gateway events that we just mentioned. And as said in the last one, we have the bytes received, bytes transferred, and then the session duration in this case. On the RD connection broker, we'll have events about the connection requests that were received and processed, as well as an event about the user being redirected to the endpoint, so the RD session host. And in terms of, as a side note in this case, the connection broker needs to have RDP enabled in order to forward the connection, because a very short RDP session will be created when the connection is forwarded to the RD session host. And this is what the output of Chainsaw looks like. And we can see that we have here the information, and in particular, to which RDS collection we want to connect to, and then in the end, to which server the connection was forwarded to. On the RD session host, we'll have all the usual events related to the RDP sessions that we have also in regular RDP servers. But then in the security event log, I wanted to bring your attention to the 4624 event, because in this case, and what happened in my incident response case, is that the workstation name doesn't match the IP address that is in the log. So here we have the workstation name, which is the session. So there was an RDP connection from the RD session host to itself, but then the IP address is their gateway. So yeah, this was surprising when I first noticed it. And then we also have one event in particular that is related to the user profile disks being mounted. And in that case, we'll be able to see user-specific registry file that is mounted. And so this is what the successful logon event looks like when it starts with Chainsaw. And we can here see the computer and then the IP address, which belongs to the RD gateway. And this is for the user profile disks as well. And we can see that we have the ntuser.dat and the user class.dat that will be mounted. The goal now is to continue the attack and break out of that RDS environment. The threat actor has established an RDP session on the RD session host. And the objective is to deploy the tools to further compromise the company's network. But the RD session host, in this case, has been locked down. And the threat actor cannot do all of the usual tricks that it can. So as the attacker will soon find out, by design, the machine cannot be shut down since it's a shared host where multiple RDP sessions are active. There is a local group policy that is in place to block command prompt. AppLocker default rules were created, and additional rules were added to block PowerShell and PowerShell's editor from running. So what does that mean for the threat actor? It means that on top of not being able to execute PowerShell or CMD, the attacker won't be able to run its own tools, because at this point, he's not a local admin. And the tools need to be in an authorized directory, which in this case is the Windows or the program files directory, based on the app default rules that were created. To bypass the restrictions and continue the attack, the following solutions were implemented in this demo. So to have a command prompt, the CMD from ReactOS, which is a free and open source implementation of Windows, can be used. PowerShell run spaces can also be, the lol bins can also be leveraged to execute FTP. So we have FTP and WMIC to have an access CMD, as we'll see later on. Then we also have PowerShell run space that can be used to execute the PowerShell commands directly. And then for the execution of the tools, the attacker needs to find writable authorized directories, which, for instance, one of the examples could be the C Windows task directory. So now let's watch the second demo. Removing this, and here we go. So the first thing we can notice is that the threat actor can only disconnect from the session host. Then the next step is to try to execute CMD, but again, it's blocked. And then if we look at PowerShell, and including the editor as well, and the 32-bit version and 64-bit version, it doesn't work. Everything is blocked. And so at this point, the threat actor can start to suspect that AppLocker is running. If now the threat actor tries to execute one of its tools, so the React CMD, it won't work again. So one of the things the threat actor can try to do is list what are the group policies applied. And in that case, the search bar can be used to execute the GP result command, or binary. And in this case, we are outputting the result in an HTML file, which we're going to open. And if we take a closer look, we'll have one rule here that will prevent access to the command prompt. And so At this point, we know that there's something, so we're going to try to bypass to have access to CMD. And to do so, in this case, so FTP and the WMI CCLI were executed, and on your left, there were some commands that were executed, UMI, ipconfig. So in this case, it was basically to just have a terminal-like interface. But then here, if we use the /c argument, we'll be able to actually execute the command. So if we continue and we look at the output in there, we'll be able to see that we have the result. And same thing with FTP. If I run the dir command, I'll have the same. So the next step there was, once we have bypassed the CMD restriction, was to bypass the PowerShell restriction. And to do that, we can run our PowerShell run space, which is, in this case, a C# project. And we're going to use the MS build executable. So with the search bar, we can start it. And at this point, since the threat actor suspected that AppLocker was running, we can use get AppLocker policy to list what are the policies in place and the rules. And based on the output, the threat actor can determine that there are restrictions in terms of the directories where the tools can be run. And now the last step is to determine those authorized directories. And to do that, the threat actor can use a PowerShell script. And when we first try to execute it, it doesn't really work, because we are in our shared folder, which is normal. But if we import the module directly, that will work. And in that case, in the output, we'll have the list. And as the example and the slides mentioned, we had, for instance, the C Windows task directory. And so now if we try to execute our CMD from React OS, so we're going to copy it to that directory. And then it should be all good. So copying and then executing, and there will be no longer any problems. So yeah, that's it for this second demo. So what did we observe? Regarding the detection opportunities, since AppLocker was enabled, we can have a look at the executables and DLLs that were allowed to run, and with a particular focus on the lol bins. We can also look at the events that were blocked, because that can give us an idea on what the threat actor tried to achieve. Since the attacker in this demo tried to execute a PowerShell script, we can have a look at the ID 4104, because usually it will contain the content of the script, as well as the path of the script that was executed. Last, Windows Defender was running on the machine, so we can see if there were any malicious activity or any malware that was detected. And in terms of the key takeaways, it's worth noting that the commands that were executed in the PowerShell run space won't appear in the PowerShell history file, so the console host history text file. And this is what the output in Chainsaw will look like if we take a close look at the allowed binaries in AppLocker. So we can see the GP result, FTP, UMI, and so on. It is time to further compromise the estate. So at this point, an adversary or the attacker will usually try to avoid detection throughout the compromise, gain more knowledge about the system and internal networks, try to gain higher level privileges and permissions by maybe becoming local admin, and then try to pivot until reaching the objective. And in this case, for instance, the threat actor can also try to backdoor legitimate binaries, perform DLL sideloading as well. And for instance, if the objective is to try to reach out to the domain controller, it can try to enumerate the AD, privilege escalate into the session host, and then move laterally to the DC if it finds the credentials or to a user that has access to it. So the attacker now is at the RD session host here, and we'll start to perform discovery on the estate. And now we have our last demo. So removing this, and we can get started. So at this point, there was the threat actor tried to become or gain more privileges and try to become a local admin using WinPwn, but that didn't work. So the threat actor tried to do some discovery and listing the different machines that were in the domain and so on. And he found one particular machine which allowed RDP connections, which is the Windows 11 machine we saw previously. And so at this point, the threat actor will log on into that machine, and the user, it will use another user, because that's the only one allowed in there, and the credentials for that second user were recovered during the initial brute force attack. And so here we are setting everything and also loading the local drive. So here's the password that we still have in our Metasploit module. And if we go back, we copy-paste it, and now we should successfully connect to the Windows 11 machine. And so at this point, the threat actor can try to identify what's the Windows version running on it. And in this particular scenario, even if despite the fact that it's a Windows 11, this version, which is from January 2023, is vulnerable to a CVE that will allow the threat actor to gain system privileges. So by doing that, the tools were copied to the session host, to this Windows 11 machine, and we have the POC that is going to be used. And for that, we need to provide the PID of the process we want to, for which we want to elevate the privileges. So that's what we find here. We have our CMD, and then if we run the POC with the PID, we'll have at the end, gain system privileges. So in this case, then the threat actor enumerated the logged on users, and we had, so here the administrator who was active, and the idea was to hijack, do a RDP hijack of that session. But as we'll soon find out, that didn't work. A password was requested because we were running recent versions of Windows 11, and in this case. So what can the threat actor do? In that case, we have local admin privileges on the machine. One idea could be to retrieve the registry hives and then try to identify credentials from there. And in this case, that's what happened. So to simplify now the attack, at this stage, the threat actor managed to recover the MS cache hash of the domain administrator user, and that hash cannot be passed in a pass-the-hash attack. So the only way to exploit it is to crack it. And for simplicity, we can assume that was the case, and that the attacker then could successfully go into the domain controller. So with that, this concludes the attack scenario illustrated in this presentation. Now let's talk about real-world attacks on RDS environments. And this is based on 2 incident response cases that I had knowledge about. The first one was conducted by WithSecure incident response team, and the second one was handled by another company. So for this first case, we had an on-premises RDS deployment, which had an RD gateway, RD connection broker, and 2 RD session hosts. The threat actor managed to access the network by using employees' credentials, and there was no brute force attempt. And when the threat actor logged on into the RD session host, the drive sharing was enabled. So in the logs, we can see all of its tooling that goes from the Kerberos executable to Rubius and so on. The threat actor carried out the attack from the RD session host, and it used the PowerShell console to do that. So the RD session was not locked down at all. And this attack, it ended up in the ransomware lockbit being deployed on the client's estate. And so this is the setup of the attack for the affected machines. We had the RD gateway, the RD session host to which the user would connect to, our connection broker, so an RDS environment. We also had like a VPN jump host, a software server, the employee's laptop, which was accessible via RDP, multiple domain controllers, as well as data servers. And so for this attack, I decided to focus on the actions performed on the RD session host. And here's the timeline of the actions carried out by the attacker. And this is mainly based on the PowerShell history file. So there was a lot of reconnaissance and enumeration that was performed. There were some attempts to do some credential access and privilege escalation. And so I won't go into detail, but for instance, there were some checks for multiple CVEs, the first one for the SAM account name spoofing, and the second one for the zero logon. So, and at the end, what we suspect that happened is that the threat actor managed to identify a vulnerable abusable certificate, which then allows lower privilege users to escalate privileges and reach the domain controller. And so now if we zoom out and try to get an overview of the attack, we can see that the threat actor managed to infect multiple machines and deploy ransomware, probably through the domain controller. That's something we could not confirm because the client restored the domain controller before any forensic acquisition was performed. So thank you. And in that case, yeah, there was a lot of lateral movement. The employee's laptop that was also used for discovery. So yeah, this is what we ended up having and how the estate was compromised. And so now let's jump into the second IR case. So for this one, it's an interesting one because it was an RDS deployment on Google Cloud Platform. And so a service account was used to connect directly to the RD session hosts. But how is that possible? It's a service account. So it was wrongfully configured, and so it could be used for login. On top of that, there was a weak password, which had never been changed in 5 years. And last but not least, the RDS session hosts were public-facing. So we have an RDS environment, which should be at least protected by the RD gateway. We have the session hosts are publicly exposed, so great job there. Next, there was some network scan that was performed using the tool Angry IP. And a few days later, after some reconnaissance had occurred, the threat actor came back and started moving laterally using RDP until reaching the internal network, which was still in GCP. So this attack, all the infrastructure was on GCP. So once inside that internal network, a second service account was compromised. And that service account could still log into RD session hosts. And really the best thing that could happen is that that account belonged to the backup operators group. And so by belonging to that group, it means that all the files can be backed up and restored. That account can log on and shut down PCs. And what's crucial here is that it can remote connect into the domain controller. So after that, the investigation showed that the DC sync attack was performed using Mimikatz. And there was an EDR that was installed, and it detected it, but it was not in the blocking. So another miss there. And so soon after, there were RDP connections from that host where the DC sync attack had been performed to the domain controller as the domain administrator. And in terms of impact, this was, again, a ransomware attack, and the LV ransomware was deployed using GPO. So now, this is the final section of this presentation, where I will go over the recommendations and how companies can further protect themselves. So one of the first things I wanted to mention is that if the network has RDP in it, one feature that can be enabled is the Windows Defender Remote Credential Guard, because that enables RDP connections and the users won't leave their credentials on the target server. So that's always a good thing. And for instance, if the RDP hijacking attack had been successful in the demo, that would have been one way to protect it. And for instance, with that, like the Mimikatz module that lists the available provider credentials would no longer work. Then, well, we have our RD gateway, but we need to further protect it. And in that case, we can use multi-factor authentication. And there are multiple solutions that will be deployed at the RD gateway level, RD web access level, and so on. And so here are a couple of solutions, and I think the two most common and known ones are the dual authentication, so for Microsoft Remote Desktop Web and Remote Desktop Gateway, as well as the Azure multi-factor authentication. And now in terms of general mitigations, it's always a good thing to improve logging, even in terms of how many events are in the Windows event logs. If there's a shared host, and in this case the RD session host, please just try to lock it down as much as possible, because in like the incident response case that I handled, there were no restrictions. So once the threat actor had the credentials, you can just start PowerShell and do some enumeration and then RDP to the employee's laptop. So really it's crucial that when you have those entry points or those shared hosts, just limit the damage that can be done by a regular user. Then always a good reminder, but yeah, keep all operating systems, software, and firmware up to date. This is crucial, even if there's running one of the latest versions. It's not always easy, but it really improves the security overall. Then if we have in an RDS environment those public-facing roles, they need to be put in the DMZ to limit as well the servers that can be exposed and limit the connections between those two firewalls. Then if we have our RDS servers, they need to be placed either under a VPN or the RD gateway, because that's the idea. But MFA needs to be enabled there, so we can prevent the dictionary attacks and if any credentials were leaked as well. Then if there's cloud infrastructure, as we saw in the second incident response case, we can deploy cloud bastions that will further protect the public-facing roles or the servers that are publicly exposed. And last but not least, and there could be more mitigations, but one key element is to strictly limit the usage of RDP and other remote desktop services within the network. We can see that RDP is difficult to detect, so if it's not locked down, or if there's ways for the threat actor to move within the system, that always it's always more complicated. So yeah, these are some of the general mitigations we can recommend for these environments. And with that, that concludes this presentation. So thank you for your attention. And do you have any questions?